All right, well, let's get started here, and please, bring up any of your questions that you might have. David was just saying that he wanted to look at some of the graphing ones on 6.3 and 6.4 and 6.5, so we're going to take a look at some of those, but please, speak up if there's other things that you want to take a look at. And things in the past are great, because basically we just have a couple weeks left, and so I want to make sure that we have a chance to review and stuff for the final. Let's see, and I think this class we might only have one more week of. Do we just have next? Let's see, yeah, we only have one more Friday, the 24th, because the May 1st is a reading day, and so we can still hold class that day. It's just attendance won't be required on that day because it's not technically one of our class sessions, but we could use that day to review for the final exam. So that's a possibility, but yeah, so we only have one more week of required attendance and stuff. So, all right, well, let's look at some of these graphing ones and make sure that you're feeling good about how to graph these logs. So when you started off talking about logs, right, remember that there's exponentials and logs undo each other, and so they're opposite operations there. And so if it's asking you to graph y equals log base 5 of x, right, we're going to take what you learned in the beginning part of Module 6, and you need to change this into exponential form, right? And so that means you're going to take the base of the log, raise it to this power, to that y power, and put it equal to x. Right, so it's kind of following this little kind of circular thing. And remember that when you're finding the log of something, right, so log base 5 of x equals y, right, this y that you're trying to find is the exponent, right? That's what you're always trying to find with logs, is what is the exponent? What is it being raised to? Right, so if I rewrite that, I'm going to have it as 5, right, to the y power equals x. And now I'm going to be using this to help me make my little chart, right, my table of values, and then graph it from there. So the thing that's different on this, and maybe I'm just going to write down a couple of steps here, just to make sure it's clear, right? So first thing that you're going to do whenever you see a log equation, a function that you're trying to graph, you always want to change that to exponential form. Right, then you're going to pick y's instead of x's. All right, so sometimes you're going to have to take a step here to solve for x, if x isn't already by itself. I'll just put if applicable, right? Because on this one, we don't have to do that. X is already by itself. And then after that, you're going to pick y's, and this is what's different, is usually with every other graphing that we've done before, we're picking x's and solve for y, but that's going to make it really difficult to try and do it that way. So we want to pick y's, not pick x's. Okay, so pick y's and solve for x. All right, so is everybody okay right there with those graphs? What's happening here? Okay, make sure those steps are what you understand to do here. Okay, so let me pick some y's, And again, remember, this is what we're going to be raising. We're going to be using that y to raise 5 to given powers. So make sure you choose some that are negative and some that are positive, but you want to choose some that are right around 0. So usually the ones that you'll pick, start off with, would be like -2, -1, 0, 1, and 2. And sometimes, you know, some of these are going to go way off the graph or going to be hard to see, but it's at least a good starting point of what numbers to kind of pick on here. So let's do that. So when I'm doing this, and maybe extend this out a little bit here and show a little bit of work of what I'm doing. All right, so on this first one, I'm putting -2 in place of my y. All right, so I'm having 5 to the -2 power. And remember that -2 power doesn't make our answer negative, it flips it, right? From what we talked about before with those properties of exponents. So that's really saying 1 over 5 squared. All right, we're flipping that 5 to the bottom, right? And now 1's on the top. So then we get 1/25. All right, so then that means my ordered pair is 1/25 comma -2. Well, 1/25 is a pretty small number. It's going to be hard to kind of see on the graph, but let's keep it there for right now. Now let's put -1 in, right? So 5 to the -1 power. That's just telling us to flip this again, so that's going to be 1/5. Right, so we get 1/5 comma -1 for another point. Right, now let's keep going. Now let's put 0 in. Remember, any number raised to a 0 power always gives us 1 for an answer. Right, so my point on this is 1 comma 0. And then 5 to the first power, right, is going to give me just 5. And then 5 to the second power is going to give me 25. So I've got a 0.5 comma 1 and 25 comma 1. Okay. So if I was to try and graph this out on a grid, right, let's see what this might look like. I'm not going to go clear out to 25 here on my X. We can probably see the shape of it without having to go out quite that far, right? But let's see here. So if I go, and maybe I'll even skip over this one as well. You can put it in there, but it's going to be kind of hard to see. All right, so if I have, let's do 1/5, so over 1/5 down 1, looks like it's going to be about here, right? That's going to be pretty close to that y-axis there. And then 1, 0 is here, and then over 5, up 1 is here. So I can kind of see the shape of it, from those 3 points. If I was thinking about, this other one, 25 comma 1, well, I'd be going over 25. Whoops, that should say 2. 1 there. Right? So it would be going over 25 and up 2. So maybe it's like clear out here, right? And so we can kind of see that the shape of this graph, just pretend I went through that point. Hard to do on this here, but this is going to be the shape of the graph. Now, the side that's going down on the y-axis is getting really, really close to the y-axis, but it's never going to be touching it. So that, I'm going to put this little dotted line here, that's called an asymptote, when it's getting really, really close to that line. Okay, so our asymptote here is the line, the y-axis, right? Or we could call that the line x equals 0. Right? It doesn't matter which way you call it, because remember, all of our graphs, when we talked about graphing, like x equals some number, those are all vertical lines. And so that's how You know, so x equals 0 is the same thing as that y-axis. Okay, so then if we were to look over here, right, in the homework question, on this one, you were just having to pick which one it follows, right? And, you know, these are all kind of going different directions. And really what, you know, I'm hoping that you kind of see is that if your, circle this here, right, if the base of your log is a number that's bigger than 1, then it's always going to have this same kind of shape to it. It's called logarithmic growth because as you look at it from left to right, it's going to be increasing. It's really slight. It doesn't increase really fast. Like exponential growth, it goes up super fast. Logarithmic growth is pretty small. Okay? It doesn't go up as fast. But so we can see that this would be, I don't know, I guess if we call this A, B, C, and D, right, it's going to be the one down here in the lower right-hand corner would be the only one that that could possibly be. Right. All right, what questions do you have on that? About any of this graphing? How exponentials and logs are together? Okay, I want to look at number 11 now too, but this time I'm actually not going to work it all out. I want you to use kind of some logic to try and think through what might be happening with this. Okay, so so this time, right, our log is a fraction. It's not a whole number, right? So it's a number between 0 and 1. And so when we talked about, let's see if we can kind of get this down here. So we know it's not going to look like this, right? It's not logarithmic growth that's happening on this. So it can't be this one in the upper left-hand corner, right? That would be if it said like log 3 of x. It would look something like this, okay? So remember, let me just kind of draw a couple of things for you to keep in mind as far as what, you know, different graphs have shapes to them. And we call these parent functions because every graph that is of that same type looks similar to it, right? So if we're talking about like y equals 2 to the x power, right? So this is exponential growth that's happening. So as we look at the graph going from left to right, it's kind of doing something like this, right? So this is, so when this number, that 2, right, the base of this is bigger than 1, we're going to have this exponential growth. Right? Then if we have a fraction there instead, so 1/2 all raised to the x power, right? Then that's going to be exponential decay. So it starts up high here and then eventually kind of comes down this way, right? And so this is exponential decay. All right, so anytime we have any kind of a fraction, right, this base has to be a number between 0 and 1. Can't be 0, right, but it can just barely be above 0. And it can't be 1. It has to be between 0 and 1. All right, and then what if we have, let's look at the log ones now, right? So y equals log base 2 of x, right? Well, again, this is going to be logarithmic growth. So that means it's going to be going up like this, right? And then the last one, right, y equals log of 1/2, right? So the log base 1/2 of x. Anybody have an idea of what you think that might look like? So think about what we have already here. What would this one look like? I said it's going to be log decay. And maybe you could use the, the pictures over to the right there to tell me which one you think it is.
The bottom right one.
Okay, so you think the bottom right one? What do you guys think? Right, kind of like we're just really eliminating possibilities, right? Because look at here, so all of these, there's going to be one of each of these, right? They have one showing exponential growth, exponential decay, log growth, and log decay. So it's kind of just knowing what you're dealing with here. So our exponential growth is this one up here in the upper right, and so it can't be that one, right? Exponential decay is this one, right? So it can't be that, right? This is our log growth. So by process of elimination, looks like it's got to be this, right, where it's going to kind of come. And remember, our asymptote, right, maybe I'll kind of draw these in also. So with logs, our asymptote is always going to be like a line straight up and down, right? So here are my asymptotes. But with exponential, my asymptotes are going the other way. Right? It's getting really close to like a y equals, some number, or a lot of them get close to the x-axis. Right? Does that help in understanding kind of a little bit about the shape of these graphs and how they're kind of similar to each other? So it doesn't really matter what number, right, I'm putting in here. These are all going to have the same kind of look to them. Yeah. So, and some of you may not have gotten to this yet, but that's okay. It's going to be good to kind of go in understanding this if you haven't gotten to this yet in your class, because logarithms tend to be something that, I don't know if it's the name of it or what, but a lot of people kind of get freaked out by logarithms. But I think once you understand that logarithms really just undo exponentials, right? I mean, in math, we deal with these inverses all the time, right? We always have opposite operations, right? If you're squaring something, you can take the square root to undo it, right? If you're subtracting something, you add it to undo it. So this is an operation, right? When you're taking the log, right, it's an operation like add, subtract, multiply, divide, squaring, square rooting, right? Those are operations. So don't think of log, the log, that's not a variable. You're not solving for log, right? You're still solving for x when we get to that. That's going to be what would be coming up later in Module 6. We'll talk about how to solve these. Okay. What things can I clarify for you? There. All right, what about, let's see.
Can we look at one that would be like, I guess the example I'll have would be like y equals log 4 parentheses x plus 8.
Yeah, so I want to look at one like that also, because that is going to shift where our asymptote is, right? Yeah. So let me see, was that in 6.4 maybe?
This is still 6.3.
I think 6.3. Oh yeah, okay. Sorry, I was thinking that it wasn't on here. Okay, so let's look at one like this, right? So now, when we have, so notice that the difference between what we have up here in this one, right? So it kind of looks like this one here. It's log growth because I can see that my base of my log is a number that's bigger than 1, but I don't just have x to the side now, right? I have x plus 2. So let's look at one like this. If you're asked to graph y equals, oops, log y equals log base 3 of x plus 2. All right, so again, just like we started out the other one, we still need to take and do these steps, right? So change to exponential form, solve for x, and then make sure you're picking your y's, and then figuring out what your x's are from there. Okay, so let's first change this to exponential form. All right, so that means we're going to do 3 to the y power. You start with your base, raise it to whatever power, right? The letter that's by itself out here, a number by itself. 3 to the y power equals all of this. So 3 to the y power equals x plus 2. All right, now x is not by itself here, so that's where that second step comes in that I was telling you about. But let's first, it's going to be easiest if we just get that 2 over to the other side. Get x by itself, right? And so that means we're going to have 3y minus 2 equals x. And so now this is what I want to put my y into. Right? So I'm going to pick y's and figure out what x is. Okay, so let me make a little, I'll make my little t-chart right here. Right? So x and then y. And then we've got to kind of, figure out, well, what are some good, y's that we want to pick? Well, I would still try and pick those, similar ones to what I picked last time, right? Maybe I'm going to pick -2, -1, 0, 1, and 2. Right? Those are at least good ones to start off with. Sometimes you're going to want to pick some different ones, and sometimes these aren't going to be, as helpful. But let's start with these, and then you can kind of see what I mean. So I'm going to put these then into my equation there. So I'm going to say 3 to the y power, or sorry, 3 in this case to the -2 power, right? And then minus 2. Kind of looks weird there, right? But remember, this is really saying, so 3 to the -2 power, we'll do it down here, is telling you to flip that, right? Negative exponents, this means you're flipping that, so that's really going to be 1 over 3 squared, which is 1/9. Right? So I have 1/9 minus 2. Okay. And you could just, if it's easier for you rather than using fractions, some of your calculators will just use fractions, and you can do that, or you can change it to a decimal approximation, because again, on this, we're just trying to pick the one that looks like it, right? On some of these, when you get to, let me pick one of these up here for a second. There was one. Oh, it must be in the next section. Okay, well, I'll show you later then. So yeah, so we're going to have, so if we just did, 1/9 minus 2 on there, you could just kind of, round that to the, nearest, like it's about -1.9. So that means my ordered pair is going to be about -1.9, -2. Right? And that's just what I get from doing that 1/9 minus 2. So I get that -1.9. Right? And then do it again. So 3 to the -1 power this time. Right? I'm putting -1 in place of my y. And then minus 2. So now I'm going to have, this is going to be 1/3 minus 2. Right? So if you do 1/3 minus 2, what do you get?
-5/3.
Yeah, and so you could leave that, the -5/3, you might want to change that to a mixed number, just because that will be hard to locate on your graph, maybe, where -5/3 is. So what would that be as a mixed number?
-1 2/3.
Yeah. Right. And then if you wrote it as a decimal instead, that would be about -1.6. Right. But it's up to you. You can leave it fractions. You can do it decimals. It doesn't really matter. Right. But whatever works better for your brain to kind of think through. All right. Then again, we're going to put our 0 in. So 3 to the 0 power. Right. And then still subtract off 2 after that. So that's really saying 1 minus 2, which is going to give me -1, right, and comma 0. Now let's put 1 in. It's usually these with the negative exponents that cause people most problems, but please speak up if you're like, Becky, I do not see where you're getting that from, right? So, oops, I meant to put -2. All right, so I really have 3 minus 2 there. So that will give me 1, so 1 comma 1. And then my last one is going to be 3 to the 2nd power, which is 9, and then minus off 2 is going to give me 7. Right, so 7 comma 2. All right, so then if I graph this, let's just do it over here so you can kind of see what is happening here. And so I can see that I'm going to go, oops. All right, so if I have my graph over here, right, I'm just going to try and put in some of these points here. So over about -2, right, down 2 would be about here. Okay, but it's not quite to -2, but it's really, really close to it. Right? And then if I do -1.6 comma -1, it's going to be about in the middle of that one there. And then over, let's see. Yeah, so over -1 down 0 is going to be here. And over 1 up 1. And then over 7 up 2. So again, I can kind of see that my graph is looking something like this. But remember, it keeps going up and out that way, and it keeps going down this way, right? Now, David, if you were to guess where that asymptote would be, where would you think it is? And how could you decide for
Around
sure?
-1 0.
And so,
Or no, it
the
would be
asymptote, it can't, like, there can't be any, any part of our graph on that side of the.
how about -2.5 0.
Okay. So maybe, right, you're thinking maybe it's between 2 and 3 here, right? So what if you tried, to put some values in, like, let's see, how do I want to say this? What if we put like let's put like a -5 in place for y, okay? Let's try and do -5. So then that's going to be 3 to the -5th power minus 2, right? And so 3 to the -5th, well, that's going to be a pretty small number.
Yeah, it's like -1.9958.
Yeah, so what does it seem like it's getting really, really close to? So it seems to me like, do you see how all of our numbers, it was like -1.6, -1.9, -1.999999. So as you keep putting more and more negative numbers in, it's just going to keep getting closer and closer to 2. All right, so that's actually where our asymptote is at 2. And the way you can see that in your equation, right, if you look here, you're thinking of, it's kind of like the opposite of what's inside that, you know. So -2 is where my asymptote is going to be. It's going to get really, really close to 2, but it's, or -2, but it's never going to cross it. Does that help?
Yes.
Okay. Because you could even put more, you know, bigger and bigger negative numbers in place of y, right? As you're going further and further down this way, what's happening? Well, you'll see it will never get bigger than 2. It will just keep getting closer to 1.99999999999. Okay, but it can never get to 2. Right? So that means on this one, right, we're trying to figure out, well, it looks like, you know, it's got to either be this one or this one. That one looks really weird because it like cuts off right there. Right, the one in the upper left-hand corner. Okay. I'm not sure if you can tell where my cursor is at. But yeah, so it looks like it's got to be this one in the lower left-hand corner, right? Because that's the one that's getting really, really close to -2, but never touching it. So that's why this is really important to keep in mind. This is telling us, right, our asymptote. Let me write it here again. Is at the line x equals -2. So it's kind of like the opposite, right? And I can't remember if I said that to this class or if it was a different class, but one student told me the way that they remember, you know, like when something's in parentheses like this or when it's inside, that you're going to be doing the opposite. Like it's not +2, right? Which is what they were trying to make it look like on this upper left-hand one, right? It's not going to be the same as that because they, you know, insiders are liars. So that's why we're going to be going with the opposite of it. Okay, so kind of remember those. Insiders are liars. Okay, so just a silly way to kind of help you remember that we've got to do the opposite there. So x equals -2 is where my asymptote's at. All right. Well, hopefully that helps because I know it's just kind of, it's easy to get all of these things kind of, you know, mixed up in your brain and stuff like that. But anything else I can clarify for you there? Anything from earlier? Is there anything in 6.1 or 6.2 that anybody needs clarification on? Or what about with your calculators? There's going to be so much stuff on this module where you've got to make sure that you know how to use your calculator. So make sure you have, you know, available to you when you're doing your homework and even during class when you're, you know, or when you're going through the lecture, if you go back through the videos after, have your calculator with you handy, the one that you're going to be using on the final exam, because I just want to make sure that you are using your calculator correctly, because some calculators you have to input it differently, and so you just got to make sure that you know which way you have to put it into your calculator. Is there anything else?
Yeah, that way you showed's a lot easier than how he demonstrated it yesterday. He was like having us solve for the logarithm for the y on the y chart.
Oh, really?
Yeah.
Yeah.
So you would enter you would do like the x value, and then you would solve the log 3, whatever x value you put, plus 2, and then you would have to solve that to get the next point, and it was kind of confusing.
Yeah. Yeah. You'll see that later on, like those of you that go on to 1050 will kind of show you that way and stuff. But I feel like, I always do it this way. I think it's so much easier. So, yeah. Okay, good. I'm glad that helped, because I know sometimes it's just like, okay, if you could just tell me what's going on there and get it down really good. In 6.5, you talked about natural logarithms is what you're going to be talking about if you haven't gotten there yet. So everybody get out your calculator, and I want to just make sure that you have found the buttons that you're going to kind of need on this. So some buttons will just say like log, right? And some might say log of x, right? Or some will say like log base 10. So there's just different ways, right? But these all mean the same thing, right? So can everybody find that that button on your calculator? Those log buttons. Raise your hand if you found it on your calculator.
I have a question. What
Yeah.
about if it says ln? That's the natural log also, right?
That is, yeah. So we're going to talk about those buttons as well. So there's going to be one that says, and some people think it looks like it says IN, but that's just a lowercase l, right? So sometimes it'll look like this, right?
I'm using a TI-36, and it has like the ln and the log, so you have to like double push it. So like one push would be the ln, and then if you double push it, it'll be log.
Oh, yeah. That's good, you know, because it's not like a shift key, right? You have to like click it twice. Is that what you're saying?
Yes.
Yeah, on some calculators it's that way. Which one was yours again? Yours is the TI
36.
36, yeah. So that one is a little bit trickier to figure out how to get to that natural log button, right? But natural log is always in base E, so that's why sometimes they will show it like this. So there's just different ways that they'll represent it, but just make sure that you have, you know, found where those buttons are on your calculator and how to click on them. So like he was saying, if it was asking you to find, so I want everybody to try and do a couple of these here, right, now that you found that button. And on all of these, I want you to round your answer to 4 decimal places. Right. That's usually with logs, they usually want you to take out 4 decimal places, but not always. So make sure you're watching your instructions to tell you where to round it, because when you're trying to find the log of these numbers, usually you're going to get, you know, never-ending, non-repeating numbers. So we're going to have to round it at some point. Okay, so let's round all of these to 4 decimal places. Okay, so for the first one, I'm going to have you try all of these, and then we'll see if you've been able to figure out how to put it in your calculator correctly, right? So let's try, I want you to do the log of 28, and then I want you to do the natural log of 28. I want you to tell me, I mean, do you get the same answer? Do you get different answers? But just write both of these down on your paper. What do you get? Rounded to 4 decimal places. Okay, will somebody share with us what you got for log of 28? What did you get for that answer? Alex, were you able to figure it out? Oh, you guys are just right over there. All right, yeah, so to 4 decimal places, all right, we got, so it should be 1.4472, right? So we want to make sure that we have 4 places after the decimal point, right? Would be what that one is. Okay, what about natural log of 28? Do you get the same thing? What do you get there? You can either say it out loud or just type it in the chat. All right, so 3.3322. Right, like I said. All right, why? Can somebody explain to me why do we get different answers on this when we're taking the log compared to the natural log?
Because of the base.
Yeah, so one thing that you've got to remember, so this top one is the common log, meaning there's like this little invisible base 10 in there. So whenever, right, you're dealing with something that just says log of some number, and that's usually how most calculators are. They're just in base 10, so that's why they don't give like, you know, log of a base. Some of them you can change the base in, but most of them you can't. It's just in base 10. And the natural log is in base E. And then that gets confusing for some people because they're like, what? E is not a number, right? But it is. It's kind of like pi. You know how we use pi is about 3.14? E is approximately 2.72, right? So it is like, you know, we just use this letter to represent this number because, so everybody find your E on your calculator. It's usually right next to that natural log button, or it's like the shift of it. So see if you can find that. But if you do E to the first power, right, it gives you that, so it says like 2.7182818288, blah, 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 right? And it doesn't stop there. It keeps going and going and going. So this is a never-ending, non-repeating number. And so we're going to, you know, just round it to 2.72 so we can have a number that we can use, right, on it. But yeah, so E is that. So it's a base that's a little bit less than 3, where here it's base 10. Right? So that's something a little bit different there that you've got to realize when you're dealing with log compared to natural log. Okay. All right. And what about the graphs of natural logs, right? And of E graphs, right? So I want to make sure you see that it's really similar to what we did before, right? So if I have, change the color here, if I have y equals e to the x power, right, that I'm trying to graph, all right, remember this e is just like saying 2.72 to the x power, right? And it's kind of cool. The reason why it's called natural log is because exponential growth, it's like really interesting, follows this, you know, so it's not quite 3, right? It's not being, you know, the base isn't quite 3, but that's about what like exponential growth is that happens in nature. So if we're talking about like an increase of population growth, with bacteria growth, with, you know, any kind of like ecosystem and the growth that takes place there, it follows the same thing. So that's why it's called the natural log. And so it's usually, so it's not used all the time, but yeah, oftentimes in sciences and stuff like that, you'll see that this is used because of that growth model that it follows. So it's still going to be the same kind of thing that we talked about before, where it's kind of going like this, right? It's still exponential growth. It's just now our base, right? It doesn't look like it's a number, but it is a number, right? It's 2.72. Now it's actually this whole thing, right? But yeah, that raised to a power, right? And then if you have like, trying to make sure they do like y equals the natural log, and usually I'll write it as a cursive L for mine, just so it doesn't look like an I or a 1 or something like that. So the natural log of x, right, is still a log graph. It's just that now our base on this, right, it's like log base E is what we're dealing with here. So it's still going to have that logarithmic growth of a graph that was looking kind of like this. Let's see where we go. Do a little rough sketch like that. All right, so again, our asymptote for any log graphs are going to be lines that go straight up and down, and our asymptote for any exponential graphs, right, are going to be horizontal lines. Okay, so don't let that ln or anything like that throw you off. Just remember, it's still a log graph, right? And this is still an exponential. Right? All right, anything else there I can kind of clarify for you? Not being very talkative today, so I cannot tell what you would like to talk about. Is there anything from 6.1 or 6.2? With exponentials? Those, you know, like in 6.2 we talked about like compound interest. Does everybody understand compound interest? What it is, not just how to put things into the formula, but do you like grasp what's happening there with that compound interest?
Are we going to need to memorize those formulas?
That's a good question. No, you are not going to have to memorize them because you guys are going to, so on the test, didn't I send your class an announcement? Did anybody get that announcement? I didn't. I will send it out to you, but your instructor should be sending one to you also. So we just received information from the department about how they're going to handle the final exam. And so you will be able to use your notes. You will be able to use your book if you have a book, but you can't use like anything on the internet or any people, right? But they're going to let you use your notes and books. So you would be able to look that up. So you wouldn't need to do it. But in the past, they've actually given that equation to you right on the question. So they might give you those those formulas anyway right there on the test. So it might not be something you'd have to look up anyway. So good question. You guys excited about that? You can use your notes and stuff on it?
Yeah, that's good news.
Yeah.
Very good news.
But at the same time, I feel like you don't want to cheat yourself, you know?
No, it's true. I mean, and I think that's
Yeah, I
one
agree
thing,
with that.
like, you still need to make sure that you study for the final exam, because for one thing, you want to know where everything is in your notes, so that if you do need to go back and find it, right, get everything all organized before you start the final exam, because it is still timed, right? You only have 2 hours to take the test. And so if you don't know where anything is at in your notes, or you haven't reviewed anything yet, you're going to really still struggle through it, and 2 hours isn't going to be enough time. But if you know where everything is in your notes, you've reviewed over things, you've done the review, you know, all of the reviews all semester long and stuff, you'll be in good shape. And then like you said, all of this, you know, you guys are going to be taking 1010, 1030, or 1040 after this class, and everything in here you're going to be building upon in those next classes. So, you know, yeah, you don't want to cheat yourself, you know, out of your education. Like you're here to try and learn this, to be able to do well, to go into those next classes. So, but hopefully it just relieves some stress of, you know, okay, I can use my notes, so I don't have to make sure I memorize everything, but make sure you're knowledgeable about the concepts and the things that, you know, are on those reviews. For sure. I'm glad you said that. Because really you're only cheating yourself, right? If you're going to choose to cheat on the final exam, you know, I mean, you're just cheating yourself. So, yeah. All right.
Have you heard about the format of it? Is it going to be like we're going to have to scan in notes, or have you heard anything about that? I mean,
So,
our work.
Yeah, so far, it looks like it's going to be, from what they've said so far, and like sometimes it keeps changing. So, like say, make sure, that students know this could change a little bit. But right now, it's going to be really similar to your, to the quizzes that you already do online. So that means there's no work that you have to upload or anything. You're just putting in your answers, just kind of like you would do like for that, any of the module quizzes, the module 2 through 6 quizzes. So, yeah. All right, well, I think I might end early today, and I'll just stick around. I know some people had some things in the past that they wanted to talk about, some reality checks and stuff like that, or, things on past assignments, because I think we've pretty much covered everything in, Module 6 so far. Next week, we'll cover the rest of Module 6, go through anything on there. So make sure you bring your questions here so we can help with that. And then we'll start reviewing for the final exam. So start going through some of those module reviews together, just to make sure you remember, because it's going to seem really weird going clear back to Module 1. You're going to be like, oh my goodness, this seems like so long ago. Did we actually do this? So it's always a good thing to go back and review over all those things. Okay, but yeah, I think I'm going to stop here now. And so anybody that needs to get off can. And then if you have some questions, though, for me, some individual questions, please stick around and I can help you with those.
I actually have a question.
Say that again?
I have a question to ask. When it comes to the last final test,
yeah,
are they going to be asking from everything from the beginning? And how many questions is there going to be?
Yeah, so it is going to be comprehensive. So that means it is going to cover modules 1 through 6. And usually it's no more than 30 questions. I haven't seen the test yet to know for sure, but I'd be really surprised if it was more than 30 questions. So just, usually it's between like 25 and 30. So that's really doable to get done in a 2-hour time span, as long as you've done your studying and, the concepts and stuff. You'll get done a lot earlier than the 2 hours.
Yeah, because I did notice that I'm a person, I can learn the things and then I move on to the next thing, and then I have to be able to go back and forth for me to be able to remember everything that I have been doing.
Mm-hmm.
That's actually what I've been doing. I've been doing like I haven't even started the module 6 yet, even though we started, I think since the beginning of this week.
Yeah.
My daughter started getting cramps. And then she got a fever, so I was so scared.
Oh, no. I know. And just, your instructors should really work with you on some, things and stuff. So let them know, if you're having some, personal issues that are making it hard for you and stuff. I know that they'll really, they want to work with you and help you. So just bring that up to them. And, if you can't get it done by the due date, check and see if you can get like a day extension or something like that. And I think that they would be willing to do that for you. Okay. But yeah,
okay.
It is comprehensive. You can use your notes, you can use the textbook, and you can use a scientific calculator, but everything else is off limits to use.
Oh, well, that's good if we could use our notes, because sometimes our notes really help us for us to be able to know what we did.
Yeah, exactly.
So I was thinking about that because I noticed sometimes when I have it like my open notes and I'm able to flip it fast to be able to at least kind of visualize what it was, what I kind of learned there.
Yeah.
I'm able to know what I was doing.
Yeah.
That kind of helps a little bit.
Yeah,
all
exactly.
Right,
yeah.
That's what I wanted to ask.
Yep. All right. Well, if there's any other individual questions, like I said, you guys can stay on. Otherwise, you're good to log off, and I will see you guys next week, and we will do some more stuff. But please reach out to me, during the week and stuff too. I know sometimes it's really hard to get, all of your questions answered on just Friday. I'm available other days too to help you. So just, send me a message. I'm happy to help you if you get stuck on something, okay?
All right, thank you. I really appreciate it.
Yep. Yeah.
Bye.
Bye. Okay, so somebody wants to look at 5.8. Was there something specific on there you wanted to look at on 5.8? Was it on the homework? Okay, so just in general, to look at some of that. So the 5.8 is where we talk about some factoring, and so there is all right, so 5.8, you talk about factoring, and with the factoring, they first talk about factoring the GCF, and then they talk about factoring trinomials. So let's look at, just a couple of different things on that and make sure that you understand. So when it says to factor out the GCF, right, the greatest common factor, you first of all got to make sure that you understand what that means. What is a greatest common factor? Right. So maybe if we have something like this, we had negative 3x to the third minus 5x squared plus, 5, I'm at 15, right, plus, let's see, 3x, right? So when we're looking at this and we're trying to find our greatest common factor, you want to first break it down by just the number. You're looking at the number part, right? What is the biggest number that will divide into negative 3, negative 15, and positive 3? Well, when the first term, it's called the leading coefficient, right, is negative, we want to use that as part of our greatest common factor. So we're going to factor a negative out of this. So when I do that, right, so negative is going to come out. Well, then I'm looking at 3, 15, and 3. Well, 3 is the biggest number that can divide into all of those numbers, right? So negative 3 is going to be part of our GCF. Then the other part comes from looking at our variables. Well, we've got an x to the third, x to the second, and x. And so again, we're thinking, okay, what is the largest variable that I can divide into each of these? Well, it has to be x, because this only has an x to give, right? So think about when we're factoring out the greatest common factor, we're really dividing it out. Okay, so look at it this way. So I'm thinking, okay, I'm going to divide each of these parts by my GCF. So I'm dividing it by negative 3x. And then what is in the parentheses, what's left here in the parentheses, is my leftovers after I divide out my GCF, right? So my GCF is on the outside. That's what I'm dividing out. Negative 3 divided by negative 3 is just 1. And then x squared x to the third divided by x is x squared. Right? Because remember, when we had this, right, that you talked about with the properties of exponents, right, you subtract those exponents. Right? So that's how we get that x squared. Then negative 15 divided by negative 3 is a positive 5. And then x squared divided by x is just x. Right? Then 3x divided by 3x is just going to give me 1. Anything divided by itself, remember, is 1. And this is where a lot of people make mistakes. They forget to keep that 1 there at the end, thinking that, oh, there's nothing left. But no, there is. 3 divided by negative 3. Whoops, it should be negative 1, not positive 1. Let me make sure I have that on there right. Right. So 3 divided by negative 3 is a negative 1. X divided by x is just 1. So I'm left with that negative 1 there. Okay, and so that would be my answer, to factor out a GCF. Here's my GCF. Here are my leftovers. Okay. Okay. Anything, do you have questions on that still? Should we look at one where we're factoring the trinomials now? Or do you want to do one more like this? Should we do another greatest common factor? You said it makes a little bit more sense. I want to make sure that it makes good sense. Let's try a different one, okay? Because I want to make sure that you're really seeing it. This time I'll have you try and figure out what the GCF is. Okay, so again, if it says to factor out the GCF, that's going to be, so let's try 18x to the third minus 27 x to the second y, and then let's do plus 9 x y to the second. Actually, I'm going to put another y here. All right, so each of the terms have an x and a y. All right, so again, right, don't get overwhelmed by all of it. Take it one step at a time, right? So just look at just the number part. Okay. What is the largest number that you can think of that will divide into all three of those numbers? You can just type it in your chat if you want, or you can say it out loud. Yeah, 9. Okay, so 9 is going to be part of our GCF. Now let's look at the x's. All right, so the x part, what is the largest x that can divide out of each of those? Yeah, just one x. That's it. Right? And so one way that some students think about it is they always pick the smallest exponent, right? So if you're looking at this going, okay, x to the third, x to the second, x, okay, this has the least amount, so that is going to be my greatest common factor. That's the largest thing that can go into all of them, right? And then let's look at the y's. What can come out of this one? Yeah, just a single y. Okay, and then in your parentheses is where you're going to put, you know, your leftovers. Okay, so try and do that, and then write your answer down, what your leftovers would be, right, in your chat box when you get it. Okay, so you said, so 2, and then x squared, right, and then minus 3, and you have just x, right, and then plus 1y, yep, or you can just say just y, you can put the 1 there or not, but either way is fine. Okay, is that good? Is that helpful? Okay, let's look at the other type of factoring then, where we're factoring the trinomials and make sure that we've got, you know, we got that down really well. And really, I just like to tell my students, it's just kind of like a little game you're playing with this, right? So when our leading coefficient is 1, which is what we're going to be dealing with on all of these in 980, in your next math class you'll learn a little bit more here. But so if it wants me to factor x squared minus 4x plus 3, right? I'm asking myself what multiplies, right, to be that constant term Notice that this is in descending order. Highest exponent, then next highest exponent, right, and so on. So we're always looking at that last term. So what multiplies to be 3, right, that adds to be that middle term, which is negative 4. All right, so that's what we're kind of asking ourselves. What multiplies to be 3 that adds to be 4? Well, on this one, there's only one thing that we can think of that multiplies to be 3, and that's 1 times 3, right? But how are we going to end up with a, oops, I should have put negative 4, adds to be a negative 4. How are we going to get these to add to be a negative 4? You have to make both of them negative. So let's see if this works. So what is negative 3 or negative 1 times negative 3? Does that give us a positive 3? And then if we do negative 1 plus a negative 3, does that add to be a negative 4? All right, so that's kind of the trick on this, is trying to remember, oh yeah, I have positives, right? So 1 times 3 gives me 3, but also negative 1 times negative 3 gives me a positive 3, because a negative times a negative gives me a positive. But when I add those together, right, I get a negative 4. All right, so then we're going to use those to kind of help us write in our factors, right? So keep in mind here, this is one factor, this is another factor. Factors just mean that they're the two things that are being multiplied together, right? Like if you had 3 times 5 equals 15, 3 and 5 are factors, and 15 is the product, right? So just understanding, you know, what do I mean by factoring? Well, I'm trying to get it into, you know, something times something else. All right, so to figure out the first part, we're going to look at our x squared. So we're thinking, what times what is x squared? Well, x times x is x squared, right? And then to find our other numbers, we do this little game here. What multiplies to be 3 that adds to be negative 4? And we said that was going to be a negative 1 and a negative 3. Okay? And so then that right there would be my answer. And you can check it by foiling it together, right? Multiplying those together, right? So let me write it here. Show you what I mean, right? So if we're foiling it, we're doing the first times the first, so x squared. The outside terms, negative 3x. The inside terms, negative 1x. And negative 1 times negative 3 is a positive 3. And if I combine these together, right, do you see how I came back up with what I started with? So I know I did that correctly. This is the way it factors. And that's the only way it can factor. And it doesn't, I mean, I guess I could say you could write your answer as x minus 3 times x minus 1. It doesn't matter which one you write first and which one you write second. Just like over here, it doesn't matter if we do 5 times 3 or 3 times 5. It's still 15. Right? So those can be written either way. All right, let's try another one and see what you can do with this next one. So what about this time if we have let's do x squared minus 8x minus 20. Okay, so we start off, what times what is x squared? X times x. And then you're thinking what multiplies to be a negative 20 that adds to be a negative 8. All right, so think of your possibilities for negative 20. And sometimes students will start off and they'll just think kind of about 20. So meaning, like, what if I went through and I figured out what times what is 20? And I'm going to work organized on this, okay? So I'm going to think, okay, well, 1 times 20 is 20, right? Then go up 1. How about 2? Is there 2 times something? Yeah, 2 times 10 is 20. How about 3? Will 3 divide into that evenly? Nope. How about 4? Yep, 4 times 5. All right, and then the next number after that would be 5. Well, we already see it here, 5 times 4, right? So then that means we have everything. These are the only possible factors. So now I'm trying to think about these going, okay, if I were to add or subtract these numbers together, how could I end up with a negative 8? Right, so which of these factors do you think I'd want to use? Which factors would add or subtract to give us 8? Yeah, it is the 2 and 10 on this. But since we're trying to multiply to be a negative 20, not a positive 20, that means one of these numbers needs to be negative. And the 10 would have to be negative, right? Because if I write down this, 2 plus negative 10 gives me negative 8, right? So that bigger number needed to be negative in order for our answer to be negative. All right, and so then I can just put those in to my answer. So I've got a positive 2 and a negative 10. And that would be my answer. And again, you could FOIL it out to check it. Okay. How are you feeling about that? Let's just do one more because sometimes they combine these two things together where you're factoring out a GCF and then you take what you have left and you're gonna factor it further, okay? So oftentimes they'll say the directions will be factor completely, and that might clue you in that, oh, I might have to factor out a GCF and then factor it even further. Okay, so what if we try this? What if we have 3x to the third power minus 24x to the second power plus 45x? All right, so first thing you're going to want to do is look to see if there's a GCF. All right, what would my GCF be? So 3x, right? So let's put that on the outside. And then if you divide each part by 3x, right, let's see what we have left. All right, so then I get x squared, I get negative 8x, and then 15. All right. Okay, but now this can go further. So we're going to do the same thing that we did on this one above, right? So I'm going to ask myself, okay, what multiplies to be 15 that adds to be negative 8? Okay, so I'm going to list your possibilities for what times what is 15. Yeah. All right, so 1 times 15, 3 times 5. But on this one, right, how are we going to make it so that they add to be a negative 8? To make them both negative. Right, so if I had negative 3 plus a negative 5, right, that gives me negative 8. And negative 3 times a negative 5 gives me a positive 15. Right, so that means So part of my answer, right, that 3x still has to stay out there as part of my answer. Don't just get rid of it, right? But then the other part's going to be these two sets of parentheses, right? Oops, what is happening there? So then that means that I'm going to have what times what is x squared? That's x times x. And then what times what is 15? That adds to be negative 8. We said that was negative 3, so minus 3, and negative 5. And so then all of this is my answer. Okay. All right. Where do you want me to go down to so you can take a picture? Is there something, one of these examples specifically, Masra? Yeah, you're welcome, Justin. Is there anything else that you want to go through, Justin? Or is that going to help you get through that assignment? Okay, awesome. Well, I will see you next week then, Justin. And Nosra, if you want to stay on and I can help you with that reality check. Ah, you guys still do Module 4. Do you have questions on Module 4 still, Justin? Or because Nosra wants to do the reality check for Module 4. So if you haven't done that yet and you want to stay on for it, you're welcome to. Okay, see you later, Justin. All right. Well, let's look at reality check number 4 then. That's the one you wanted to go through, right? Do you want to unmute yourself and just talk with me? It looks like you are unmuted.